Welcome back to Siberia Tutorials. Today in part 4 we'll be learning about variable name restrictions as well as primitive data types. Let's take a look at the homework answers. I wanted you to declare two variables of the int type and to assign appropriate values to them both. Here I wanted you to practice concatenating strings with variables and remembering the appropriate spaces to make sure that your words don't run in together. And I also wanted you to practice using brackets to force a certain order of operations in order to get the arithmetic performed first before it's concatenated with the string down here. Now let's take a look at variable name restrictions. The very first character can only begin with an alphabet letter, an underscore, or a $sign, but by convention it is recommended that you use a letter, in lowercase specifically. And for digits, you're allowed to use them, but it can't be the first character in your variable name. There are no length restrictions, so you can have your variable names as long as you like, and they're case sensitive as well, and you can't use reserved keywords. So let's take a look at what that actually translates to when you're doing it in the IDE. So let's say we want to create an int. It must begin with a letter, so let's say test equals 10. So that's fine. Or it could begin with an underscore. Oops, that's not an underscore. Or it can begin with a $sign. That's perfectly fine. But if you try to put a digit in the beginning, your IDE is going to start complaining. If you place the digit anywhere else, that is perfectly valid. There are no length restrictions, so if you wanted a crazy variable name like this, that would be perfectly valid. But of course you would have to type it out or copy and paste it every single time, so that's not really the most practical name that you could come up with. Variable names are also case sensitive, so if you had this copied and pasted, then your IDE would also complain because you have two variables with the same name. But if you modified, say, this part and put it in uppercase, then those would be two completely different variables. But if you look here, I wrote down that the convention is camel case. So all it means is that you aren't restricted by the language itself by, like, for example, if you wanted to write test equals 10 all in caps, that would be fine grammatically speaking, but that would convey something that is not intended. And I'll talk more about it later when we get to that point. But just understand that by convention, you should use camel case for variables. And all camel case really means is that you start with lowercase with the first word that you're typing. And then for each new word that you type, you start off with a capital. So like this. It's called camel case because of this apparent hump in the middle of the word. And lastly, you cannot use a reserved keyword. I'm not going to go through every single one of them, but if you take a look here, public would be an example of a reserved keyword. So if I tried to create an int called public and set it to 10, your IDE will complain. You're not supposed to use reserved words because they hold a special meaning in the language. Now let's talk about the second part of this lesson. Previously we talked about data types and we know two of them already, right? So data types that we know, string and int. But in Java there are a total of 8 primitive data types, and anything else is considered an object. So the 8 primitive data types that we have are right here, and they can be vaguely divided off into 3 separate groups. You have the non-numerical ones over here. These ones are used to represent integers, and then floating point numbers for the last 2 right there. Let's take a look at them in more detail in the IDE. I think it'll be easier if I show you examples as we go along. So as you can see, we have the 8 primitive data types here. First of all, we have Booleans. When you have a Boolean value, it can either evaluate to true or false, and that's it. It cannot be converted into any other type, it's just true or false. So these are great when you're storing a value that has a dichotomous value. So say you want to check if your TV is on or off. You might create a variable like this. You could either set it to true or you could set it to false. Next we have char, and char is short for character, and these are representative of Unicode characters, and if you like you can go to this site right here to look through a bunch of them. So you can look through them by scrolling, or you can select search for the character that you want over here. So for example, let's say I have a deep fondness for dingbats. I can search them up and click here to take a look at all the different ones that they have on offer. So maybe I have a great fondness for black safety scissors and I want to use it. So what I would do is look at the Unicode number. So that's 2700. I would go back and I could create a char. And one thing you need to note is that when you're using char, you use single quotes. So remember, double quotes are for strings and single quotes are for char. You would type \u and the associated Unicode number, which is 2700. So if I wanted to print this out, I would get a pair of scissors right here. Now, for this subsequent section, these all deal with integers. We already know this one. We've learned how to use it. And the only difference between this and the other three is the range of numbers that it can accommodate. As you can see, byte is the smallest with pretty small numbers. And you have longs with astronomically huge numbers. The only real benefit of using byte or short instead of int is to save space. Be a bit generous with which one you end up picking, or if you don't feel very nitpicky and you don't want to optimize your program, you could just use it. You might want to use byte if you're, say, representing the age of someone, especially if you're representing the age of kids in elementary school. You could type out byte and write child age and set it to whatever you like. And in this next section here, we're dealing with floating point numbers, or in other words, numbers that have a decimal point. So say you want to represent pi as a double. This would work perfectly fine, but say you think it's a little bit overkill. You don't need to store it with 64 bits. You can store it with float instead. So you might try and do this, but you're going to encounter an error. And the reason that this happens is because when you ever have a number with a decimal point in it, it is automatically, by default, assigned the type of double. And when you have a double, it could be a pretty big number. And if you try to squish it in a smaller box, you might end up losing data. So it gives you an error because it's not sure if that's what you intend. But you really know what you're doing. You know that this number can easily fit into a float. Then you can put an F afterwards to show that, hey, yeah, this is totally intentional. I want a float. You can use a lowercase f or you can use an uppercase F. Both are fine. The same is true of these four over here. You get a default of int, and as you can see, I put an asterisk right here. So for example, you might want to store a number as a long for a really big number and assign it a value of I don't know how big that number is, but if you read the error message, it'll say that, hey, this number is way too big. This is not doesn't fit as an integer. but you know what you're doing. You know that it will fit within a long. So what you can do is put L in lowercase or uppercase to indicate, hey, yeah, I want a long and not an integer. And if you're curious about the maximum number that floats and doubles can hold, you can take a look over here. So as you can see, they can hold pretty big numbers. But the problem is floating point numbers aren't very accurate. It's due to the way that numbers are represented in the computer. They're represented as binary. So unless the number that you're looking at is a power of 2, then whatever you get is only going to be an approximation. So if you need any form of accuracy, if you need precise accuracy, so say you're doing titration in chemistry, then I would not recommend using floats or doubles. So now let's take a look at the homework that I've got for you. Let me know which of the following are valid variable names, and you have to tell me why that's valid. And a bonus question is, which ones out of these 6 actually follow the correct convention, even if it's technically valid? Your second assignment is to look at these 5 scenarios and tell me which primitive data type would be the best for representing that value.